Okay, another example of the chi-squared goodness of fit test. And I have it here, and you might want to pause the slide and read it. The quality control manager of a plant that makes peanut M&Ms wants to determine if the proper distribution of colors is being mixed into the bags. All right, now a couple of years ago I got this information. What percentage of colors do you make in your M&Ms? And I got this distribution: 10% brown, 20% blue, 30% red, so on and so forth. So a quality control manager would be taking a sample of bags and measuring, counting how many of these colors are there. So this quality control manager got a bag, and he counted 300 M&Ms in the bag and counted how many of each color. Here is a distribution of colors. And is there enough evidence to conclude that the distribution of colors in the bag is not what the managers want? In which case they would shut the machinery down and go go fix the problem. Okay, so this would be the observed distribution. Now, what would be the expected distribution here? I'm not saying that the distribution of each of these should be the same, but that the distribution should follow this percentage. Therefore, my null hypothesis is the distribution of colors is 10% brown, 20% blue, 30% red, etc. And the alternative is that the distribution is not that, in which case I'd have to shut down and fix the machine. In this case, I have a critical chi-squared with alpha of 0.05, degrees of freedom of 5 once again, and it's the same, 11.070. The expected distribution is a little harder to come by. If I expected to get 10% brown, then 10% of 300 is 30. 20% was blue, which is 60, and 30% red. So my expected distribution is not the same, but it's supposed to follow something different. When I calculate chi-square in this case, though, I end up with 8.961. Once again, 30 minus 30, 35 minus 30 is 5. Squared is 25. Divided by 30 is 0.833. And I just did that same procedure. Since 8.961 is less than 11.070, I do not reject the null. Step 5, the distribution of colors could be 10% brown, 20% blue, 30% red. So there's not enough evidence for me to shut the machinery down and say, oh, I have evidence that this is not mixing properly. Don't have enough evidence to conclude that yet.